Morning, everybody. I'm going to be brief because I think my time of recording my microphone might run out. Anyways, we are testing on Thursday, chapter 26. If for some reason you would prefer or need to take the test on Wednesday because of a test load on Thursday or whatever, reach out to me and I can try to make that work for you. We'll be done with content, so that should work. Let's see. Today we're doing a lab today called Mach One. There's a PDF of it attached in today's outline in today's folder. There are two videos for data. The second one was kind of because I forgot to add it to the first one, but you need to watch both of them for the data. I want to point out here, as you see on the smart board here, this is the equation in your lab manual. The speed of sound is equal to frequency times wavelength. The frequency is easy to find. That's on the tuning fork. Okay, and I tell you what those are in the video. The wavelength is this equation, 4 times this stuff. Well, this is the diameter of the air column, which I tell you in that short data video number 2, times 0.4. Then you add that to the air column that I will narrate to you and tell you in the video. Then you multiply that by 4, that equals the wavelength. The picture that you're going to draw in your pre-lab is this. It's an exterior column. That's the clear column that I'm using in the video. And this is the white plastic column that I'm using in the video. Okay? So what's happening is we're trying to get the sound to resonate at the first antinode. If you were to continue this and make a standing wave, it would look like this. Okay, so this is the first antinode. This is the second antinode. This first antinode actually comes 1/4 of the way to the full wavelength. So that's why we're going to multiply this distance right here, which I will tell you in the video. We're going to multiply that by 4 to get the wavelength. But we have to do this little correction factor first. Okay? So then once we multiply it by the tuning fork frequency, we get the speed of sound. And we're going to do a percent error. The known value for the speed of sound is 330 meters per second at 0 degrees centigrade. Well, it's 21 degrees centigrade in the classroom when I was recording. So for every degree above 0, it goes 0.6 meters per second faster. This is all in your lab manual. So it's a 0.1 meter per second increase. So we're going to take 0.6 times 21, and then we're going to add that to 330. Okay, that'll give us our accepted value, and then we're going to do our percent error, which is the actual, which will be this number that we get, minus the experimental, divided by the actual, and then times 100. So you're going to do 4 of those. I do 4 tuning forks, and I give you the data for all 4, and you're going to do 4% error calculations. This can be a handwritten lab. You're just going to take a snapshot of it or whatever, and you're going to upload that, post that on Schoology for an assignment. I think I'll put the post up in Wednesday's folder. Okay, so you have some time. So actually, no, why don't I put it? I'll put it on today's folder, just so you remember what day we did it, and that's where the post will be. So I'll put an assignment submission on that. Okay? Otherwise, we're going to do 2 short little demo labs tomorrow. And you have a little bit of content, a little bit of video stuff today. Pretty light day, pretty light week, really. Wednesday will be a kind of a catch-up day, work day, whatever. Get ready for the test day. And again, reach out to me if you need to make arrangements for a different test time other than Thursday from 9:30 to 3:30. Okay, hope you're all doing well. Take care.